Hey, it's Fran, again, in the lab. Fran Lab. Wait, I thought you were moving out of Fran Lab, shutting down Fran Lab and all that. Well, actually, it's not your imagination. I am. Actually, it's still being, it's sort of a quarter Fran Lab right now, but I still have my main desk set up, and I'm taking a break this morning to do a little video because I have to do a repair. A vintage Vibutron came in that needs a little work, and so I thought I would take the opportunity to shoot a video of the repair and give you a little look into the other world of Fran. Got the scope on, gonna do some tracing, signal tracing, and so let's go take a look at the Vibutron. Alright, so this is the Vibutron. This was made in 2008, so it's a little vintage. It's one of the middle run Vibutrons. Yeah, I made this board myself from raw stock. This is when I was doing them in my home lab, etching and drilling. And it's also conformal coated, so it's got that extra layer of protection. And it's a single-sided board. I only ever did single-sided in the old days. The input-output audio buffer chip is a TLC2262, which I use because I use this chip in a lot of my designs, especially the ones after 2000, because it is one of the quietest, loudest audio chips that you can get. It's rail-to-rail, super, super low noise. So taking a look at the trace on the scope to see what this looks like. Oh, we got it working here. Okay. So, yeah. Looks like the bias was off. So that's the amplitude. Changing the amplitude of the op-amp driver for the FET. And then the offset bias. You can change the waveform, center of the waveform. That looks about right. I'm going to change the output waveform from sine to triangle wave. Looks good. Square wave. Yep. Alright. So that's the proper output. And if you look at the op amps, all right, there's the that's the output drive for the MOSFET coming out of the op amp buffer, and it's the preamp. That's the bypass. All right, so it's looking good. All right, so that's the through signal. It's the bypass signal. And that's the effect. Change the speed. Change the mix. That mixes the effect with the through signal. And you'll see that little undulation there. That's the slight phase offset. Creates that sort of jello-like wobble, but that really adds to the tone. Right. All right. That is realigned. So the heart of the Vibutron is the signal generator. It's the ICL 8038 CCPD, which was originally made by Intercell, and Intercell stopped manufacturing this chip in 2002. So after that, there was a scramble to get this part to continue making the Vibutron. And around the time that this was made, around 2008, there were still like some knockoff chips and some rebranded Intercell chips that were being sold by NTE and some other sort of vintage replacement parts companies that were essentially Intercell chips that had been rebranded. And there were some other sort of side market chips that were sort of unlicensed knockoffs that came out after Intercell stopped making the chip. But around the time that this Vibutron was made, around 2006, 2008, that chip was going for like $50 a pop if you bought like 100 pieces. So the Vibutron was a very expensive pedal to make at the time, and but the chip was really necessary. It's the heart of the pedal. But one of the peculiarities about designing the Vibutron was that I wanted this to be a 9-volt battery effect, which it is. It's a 9-volt effect. But this signal generator really wasn't designed to work on a 9-volt single-sided supply. It's so at 9 volts, single-sided, it's really running at below its spec. It's really designed to run around 18 volts, like plus minus 9 volts. But running it at this voltage, it's really, since it is running below spec, there was a lot of design creativity to get a consistent product. So one of the things I had to do was build this testing jig. I made this, it's a mock-up of Vibutron with an external board with a socket on it, that I could set this up with my scope and my signal generator and look at the basic symmetry, amplitude, and distortion, and select out chips based on running at 9 volts, and so that to make sure that the chips that I selected would operate within the frequency range and the control range of the hardware that I had in, like my control pot and such, and that it would operate in the circuit within spec. So I had to select out every single chip, and even with really high quality Intercell chips, I was still rejecting a good 25–30% or more of the chips just because they were just too far out of spec to run at this voltage. But even the chips that I selected out that would actually work, I still had a challenge of consistency to make sure that the chips would perform, have the right amplitude, and have the right control specs. So I had to put a buffer amp in between the signal generator and the MOSFET. I'm using a 2N7000 N-channel MOSFET to actually control the audio for the effect. And so I have this buffer op amp and several controls that I can use to control the specific gain of that op amp to trim the amplitude, because the amplitude out of these signal generators is going to vary a lot, particularly in the sine wave function at the lower voltage. So I had to be able to get a consistent output so that I could drive that MOSFET, and also I have to set the bias for each MOSFET that I put in there, because they're all going to be slightly different, and just find the right balance point to get the sweet spots that it operates and sounds correct, so I can get consistency. So yeah, nothing really wrong with it. Just needed to be readjusted. I just had to spin those trim pots and get the contacts to contact better. I really hate trim pots in designs for this reason, because over time, they all get dodgy. You know, nothing to worry about, nothing to repair, just a realignment. But, yeah, it's what I do at Frantone, you know, the occasional realignment or repair. I was concerned that op amp might have been blown, because I have had ones in the past, because they are CMOS. They are susceptible to static destruction, so you can have situations where a person's plugging one of these in and they've got a big audio chain, or if it's in like a concert arena, you can actually get some pretty high potentials, difference in voltage potential between ground and line, audio line, and sometimes these things get blown up just by plugging them into a rig that's just out of balance, and you've got a high potential there, and you know, whammo. Can happen. Not in this case, but I really designed these to be bulletproof, and they really are for the most part. It takes a lot to kill a Frantone pedal, but, you know, I'll be putting this one back together. The owner will be very happy to get their newly aligned Vibutron, vintage Vibutron. So, anyway, it's a little insight into my Frantone world on Fran Lab, so I'm glad I was able to take this little break from the moving and the dust and everything, which I woke up this morning pretty hoarse from breathing in dust all day yesterday. I've been coughing up junk. Hopefully I don't have the flu, so that would be bad. But yeah, I am still moving. It's not like the whole thing was just a fever dream that I woke up from this morning and it's not happening. No, it's very much happening. But I'm going to leave this table open as long as I can for doing work and stuff. If I get ahead on the moving stuff to storage, then you know, maybe I can shoot another video. I'd like to do the Halloween video if I can for Halloween. But anyway, but that's it. Thanks for watching, and thanks to all my patrons, especially all of you new patrons on Patreon. If you like what I do, if you like this video, you like my channel, then consider becoming a patron. It's easy to do. You just follow the link in the description. And yeah, that's it. Thanks. I'm Fran. I'll see you around real soon. Bye!